Witam wszystkich bardzo serdecznie, Marcin Mazur, Arista Network Central Eastern Europe. Zapraszam na prezentację Shona na temat tego, w jaki sposób wykrywać w sieci aspekty telemetryczne. Floor is yours.
Thank you, Marcin. So, afternoon, everybody. I try and keep it a nice pace so everybody can follow, but if there are any questions, just let me know. So, just to introduce myself, I'm Sean Flack. I work in London, and I cover most of Europe for Arista. Today I'm going to talk to you about EOS extensibility. So EOS is our operating system, extensible operating system for our switches. And today I'm going to talk to you about how do you unlock application visibility. So how do we provide an insight into what's going on within applications? So to give you a bit of background as to who we are, we are a switch vendor, a data center switch vendor, and right now we're in 7 of the 8 largest cloud providers out there, and also 8 of the 10 largest investment banks. And we're creating features that really differentiate ourselves from the traditional switch vendor, and we're actually shipping these solutions today. So we can give you a demonstration and kind of give you an insight into some of the features we've created. So, looking at the past, traditional switch vendors, the operating system historically has been bound to the hardware it's created for, meaning that particular features are made for an ASIC or for a switching ASIC created by that vendor. If you want to add new features, it's very much dependent on the ASIC supporting that feature. What we're doing differently is by using merchant silicon from the likes of Broadcom, Intel, June Networks, and Fulcrum. These vendors are actually creating very high density, very feature-rich switch ASICs that have the features already. We can create software where you load one version of code across any platform, so it's the same binary image that you load across any platform will work with the different vendors that we have, or that we use in our switches. And there's no linkage to the application. There's no requirement for the application you're using. It should just work with anything. So in terms of our partnering and how we're giving insight into the applications, we work with a number of different partners. Those include VMware, Palo Alto, EMC, F5, these kind of best-of-breed vendors out there. So giving you freedom to choose which vendor you use for your load balancing, which vendor you use for your firewalling. Pick and choose whatever's right for you, and we can integrate with them. And part of this really is, providing these insights into the application and insights into the vendors that we interact with. And really, the foundation of this is the operating system. So by looking back at the market and looking back at how things were how operating systems were created historically, we're able to start from the ground up. So we started off in 2008 officially, and we didn't have the decades of code behind us to put into a product. What this meant is that we could look at the way operating systems are created and start from scratch. So we decided to essentially make our operating system completely Linux-based, meaning that it's completely unmodified as well. You can take a Fedora package, drop into the bash shell, load the package up, and away you go. On top of this, we created what we call system database. So system database, it's got a no label. So system database is one database that every process on the switch forward state into. Every other process that needs to listen to that state will then receive it. For example, if a routing update were to be received, it would be pushed into the database. Any interface that needs to receive the routing update will then receive it. The benefit being, if a process were to have an issue, bugs happen, right? If a process were to have an issue, the process can be killed, restarted, and pull the state from the database and carry on. Now, down to application visibility and how are we interacting with other partners really. By having this modular platform, we're able to interact with the likes of OpenStack, VMware, Riverbed, Palo Alto, whoever it may be, and pull data, or they can pull data from us using our API. As I mentioned already, it's Fedora underneath, meaning that people who have created these add-ons or these packages for our switches are just creating them as they would on a regular server. Now, network telemetry, what is it? It's kind of it's this linkage between infrastructure and application. Critical real-time information, so pulling information from the application infrastructure into the network, so the network becomes aware of the application underneath it. We're able to use dedicated tools or differentiated tools to proactively detect issues going on. So if the network can see an issue happening, it's able to push a notification to various applications and they can react accordingly. So it's really around the combination or the interaction between the network and the application, and how do we make that easy. So traditionally, there you go. So traditionally, people probably know this troubleshooting methodology, right? There's an issue with the network, you look into it, the network is slow, the applications team are moaning at you saying that their application's not working as they expected. Therefore, you start to look at show outputs, you cannot really tell what the issue is. You then go away, add a sniffer, wait for the issue to happen again, and 9 times out of 10, you wait days, weeks, or even months, or never, until you actually find out what the issue is. By providing various inputs into the system or various visibilities into the network infrastructure, you're able to give information whilst the issues are going on. So by providing state to the application can respond to the issues going on. These are with things like latency analyzer or event triggers. So if an issue were to happen, you create a trigger, and then the actions are kicked off. Event monitor. So why not run a database directly on the switch, and any MAC address change, routing change, ARP change, or multicast change, you push into the database, meaning that you don't have just a point view of what's going on. You're able to look back in time and see when changes what happened. So if you said, okay, a server fell off the network an hour ago, what do you traditionally do now? You say, show MAC address table, and there's no MAC address. What you can actually do with a database or an SQL database running directly on the switch is see exactly when it fell off the network. And that goes the same with routing and multicast as well. One other kind of interesting possibility this opens up as well is if you are doing an upgrade on a switch, you can take a snapshot of the database, so all the routes, the multicast entries, the MAC addresses, perform the update, and then when the switch comes back on again, compare the database you see now with the one before and see if anything has changed. So after you're doing the update, you might notice that 2 routes have disappeared. That could trigger an issue, or that could indicate there's an issue going on. And really, what does it all add up to? It just makes troubleshooting much easier. So how do we make this work? This doesn't work. So how do we make this work? Again, by using Linux. The underlying operating system is Linux. Run uname and you'll see that it looks like a Fedora server. Every single interface is visible by the underlying operating system or the underlying Linux operating system, meaning that you can interact with the control plane. You can receive data and react accordingly. Now, that's all well and good, but how do we make it easy to extract the data? So by using an API, so are you familiar with JSON? So remote procedure calls, pretty standard stuff, right? Why not allow the command line to become visible via a proper, tested, standard API? And when we say standard, it's using the same syntax that you would if you were configuring a switch. So you have show commands, show interface, show run, and the output is shown in JSON format. The configuration is very easy, 2 lines in the config, and then we start to have this command API Explorer. So let me just show you how this is set up. So I can literally run a command here. Can you see that okay? So if I say show VLAN, we then get the output on the right-hand side in JSON format. Now, it's pretty static, right? It's nothing that exciting to see there. But when you start to interact, or when you start to use that to interact with an application or create a Python script running on a server, you can then start to view what's going on within the network. I'll give you a few examples as well. So a couple of examples of this would be a Splunk plugin. So are people familiar with Splunk? It's quite well used in the industry now. It's great, you know, you can push any data into it, you can push any logs from any server, as long as it's a machine readable or a searchable or has searchable content. What we're doing with the API on our switches is actually pushing interface counter data into Splunk, latency analyzer data. So latency analyzer, what this actually is showing you when congestion is happening on the switch. So if you have 2 ports receiving data at the same time, sending to one port, inevitably you're going to have to buffer data. So what we're actually doing is pushing this information into Splunk and then showing this on a graph. S-flow information, so you can start to pull out GeoIP data, knowing exactly where your traffic is coming from and being pushed around the world. Capacity planning, so how many entries do I have left in my TCAM? How many ACL lines do I have left? And even how many ports am I currently using? VM DevOps information, so where is my VM in the network? So you can actually see where VMs are located, if they've been moved, and which server they're actually attached to. Network topology and custom scripts. So I'll give you a quick demo of Splunk. So essentially we've created this dashboard. So if you go onto Splunk's app store, you can actually search for Arista, download this, and away you go. At the same time, you can download a virtual instance of our operating system, completely free to anybody. You just register, log in, download the VM image, and you can run it on KVM, VMware, whatever you want to. And you can then start to send data from the operating system into Splunk. So on here we have aggregate traffic across all the switches in the network, various syslog output, so you've got the various thresholds in there. Hope that's easy to see. No, it's not at all. One second, I'll make this a bit bigger. Okay. Okay, it's a bit easier to see now. Okay, so you basically have a dashboard here that has all the information being sent to it via the API, and this is live. This is not, print screens or anything. This is data collecting from our lab right now being pushed into Splunk. So you have on here traffic across the network, all the syslog updates in here. So you can see all of our switches configured on the left, severity of the message. You go down, we find out that a particular switch has had error disable on a few ports. Network topology, so from the LLDP neighbor information, we're able to build a topology of the network using a plugin from Splunk. So this is our kind of harebrained spider web of a network we have in our lab, and it's pulling the data from LLDP information, or the CDP equivalent. Interface rates. Inventory. So inventory data can be easily taken from a switch. So if you want to know how many switches do you have out there, which version of code they're running, what are the serial numbers of the switches out there. You can pull them out into a table and then print this off. Power consumption information. So we can actually see how much power each switch is using over time. And because of Splunk, you could then push that into you could then pipe it to an output and see how much power you've used over time. And then lastly, I'll show you the S-Flow output. So using a regular Splunk plugin, we're able to push data into location information. UIP. There you go. So what it's actually doing is taking the GeoIP information from the traffic live and working out where it's being sent in the world. So you can see from here we have traffic from the UK going to somewhere in South America over to Santa Clara. So that's one example of the API, and that's purely using the JSON-based API. We're able to create that plugin. All it's doing is polling the switch using JSON commands and pulling the data back. Another example is Graphite or CollectD. People heard of Graphite? Essentially, Graphite is a graphing tool. CollectD is a daemon that runs on a server, collects data, and pushes it to Graphite to be shown in a graph. Graphite, you can add flashy dashboards to it, you can make it look very similar to Splunk, and it's free. Because CollectD can run on a regular server, it can run on our switches as well, or any switch that is Linux compatible. And again, we're just pulling data via the API and pushing it over to Graphite. I'll try and do one go. There you go. And again, this is live data being pulled from the switch via the API over to the dashboard. So we have optical levels on the top left-hand side. So this is telling you the optics within the switches, how much power they're transmitting, how much power they're receiving. Temperatures, CPU information, I'm pretty sure that is at the bottom. Yep, CPU information on switches. So you can see a spike on here at about 1 o'clock. That may indicate an issue with an application that has an ARP storm or a broadcast storm. And then we can see traffic going in and out of various interfaces, and also the memory. Now another possibility. Everybody talks about automating everything right now. So you may have heard of Ansible or Puppet or Chef, using that to automate a server environment. So what we can actually do is run Ansible, Puppet or Chef directly on the switch. You can then create playbooks or recipes, whichever flavor of automation you're using, that then interact with the API. So we create the playbook talking to the API. You can queue up changes happening within the environment and then push them to the switch. So we might say, okay, change a VLAN. Typically, you would have somebody log into a switch, create the VLAN, hope they didn't type in the wrong commands, and away you go. Now what we can do with some of these automation tools is have a change queued. You can review the change and then push the change to a switch at a time that suits you. Come back in the morning and review if the change committed successfully. And again, all using the API. Jabber over the CLI, XMPP. So all we're doing here is presenting the CLI to Jabber, XMPP, and communicating with every switch at the same time. If you want to find a MAC address in 50 switches, you run one command, and the only switch or the switch with the MAC address, that will respond. Nobody else will. So rather than saying show MAC address table and then going through one step at a time, you just have every switch respond and you find it straight away. And finally, an iPhone app. Why not? You know, it's an API. You can talk to it over the RPC, JSON, create the iPhone app, talk to the switches, find out if they've got any issues. And at the same time, you know, right now it's pretty basic what we've got. We've got LLDP information, version information, switch port information, and you're pulling that from the switches. Why not make it a bit more feature rich? You know, start to pull error data, start to pull application data, and pull it into the iPhone app or your iPad app, whatever it might be. And this is all possible over the API. So these demos that I've shown, Graphite, Splunk, we can do a demo of those today. And also one other point to note is also OpenStack and NSX. So we can demo this as well. So I think we have a demonstration at about 4:40 that we're showing this off. So if anybody would like to come along and see any of these application visibility extensions going on, or OpenStack or NSX, just let us know. So I will leave you there. Any questions at all about the API and kind of integration?
Może ktoś ma jakieś pytania? Do you have any questions? No.
Okay.
So thank you very much for
Thank
your
you.
speech.
Thank you, everyone.